Not too long ago, China announced an ambitious and promising space program. This program included plans for the creation of their own multi-module, fully manned orbital space station, as well as the construction of reusable space transport systems for manned flights to the moon. However, upon further investigation, the plans of the Chinese turned out to be much more ambitious than originally anticipated. The achievements of Chinese engineers made the leaders of the space industry, the United States and Russia, worry. This is an example of one of the rare cases in which a country is doing more than it reveals. Recently, it became known that the Chinese are also developing an ion engine with fundamentally different characteristics than expected. Moreover, China has also begun testing new engines for their spacecraft. It is important to note that this is happening without any fuss in the press whatsoever. It seems like it's time for us to learn Chinese, ladies and gentlemen. China is secretly testing super powerful ion engines for flights to Mars and other planets. Where are the Chinese going to get the energy for this? Let's start at the beginning and proceed in order. Over the past 5 years, China has completed 152 space launches. This exceeds the number of launches completed by any other country in the world, even the United States. This was not always the case, however. Until 2018, China was not known as a leader in space technology and/or rocket science. See for yourself. In 1976, China created technology by which satellites can return to Earth. However, they were the third in the world to do so. To continue, in 2003, China became the third largest space superpower in the world to have its own manned spacecraft, making them the third best again. Very few people would consider this a success. In 2007, China was the third in the world to demonstrate possession of legitimate anti-satellite missile technology. Also in 2007, China put a Lunar Orbiting Automatic Interplanetary Station, AMS, into operation. This is an unmanned spacecraft designed to fly in interplanetary space. In 2012, with the help of their new AMS, Chinese scientists carried out a survey and study regarding asteroids. In 2013 and 2014, China was able to reacquire a lunar rover, a lunar landing spacecraft, and a re-entry vehicle from lunar orbit. The only thing that darkened the Chinese government's joy of having made these achievements is the fact that China was not the first to discover these technologies. Permanent third place after the United States and Russia may very likely have stirred up little brother syndrome in Chinese scientists. For ambitious people, this is a very unpleasant feeling. When you're referring to an ambitious country, however, this is doubly unpleasant, especially when the elder brother, personified by the United States, constantly reminds the little brother of his superiority. However, the Chinese did not break down and continued to work hard. And so in 2018, China finally became the world leader in space launches. During that year, the country made 37 successful launches, which means that every 10 days, China sent another mission into space. In 2021, China plans to make more than 40 space launches. The plans are not only about launching satellites. The Chinese will also launch the base modules of the Tiangong-3 manned space station into orbit. In order to send the entirety of Tiangong-3 into space, this project will require 12 launches. By 2022, China will have its own heavenly palace of sorts in orbit. When translated from Chinese, Tiangong means heavenly palace. What is perhaps more surprising is that less than 400 kilograms of fuel will be required for a year of maintenance at the Tiangong station. For example, the ISS requires about 4 tons of fuel per year to keep it in orbit. This is a savings of tenfold, not only in fuel, but also in payload. The Tiangong-3 space station will receive 4 ion engines. This should be enough to stay in orbit. If these plans become a reality, then the Tiangong-3 station will become the first manned space station object to use ion engines. I must say that ionic propulsion systems already exist and are in operation, but only automatic stations and satellites are equipped with them. The drawback of the current Hall effect ion propulsion system is very low thrust. Therefore, such engines cannot be used to launch any vehicles from the surface. For example, an ion engine will accelerate your car to 100 kilometers per hour for about 4 days. A conventional internal combustion engine can complete this task much faster, in 5 or 10 seconds, the time depending on the model and brand of the car. However, this type of engine has a high specific impulse and rate of economy. Its resources can range from 10,000 hours to 100,000 hours. In zero-gravity conditions with sufficient long operation of the ion engine, it is possible to accelerate the spacecraft to speeds that are currently inaccessible to any other existing types of engines. The principle of operation of an ion engine is to ionize the gas and accelerate it by an electric field. Mostly inert gases are used, xenon, argon, and so on. The gas is fed into the ionizer. The electric field accelerates the gas ions, and a mixture of positive ions and negative electrons is formed in the chamber. Electrons are neutralized by cathode grids, while ions are attracted to other grids. A large difference in electrostatic potential between the grids accelerates the rate and consequently throws the ions into space. Due to this ejection, acceleration occurs. This is how Newton's third law of equality of action and reaction is realized. The ion engine can develop a specific thrust of up to 4,500 s. For comparison, the specific thrust of solid propellant rocket engines reaches 250 s, and for engines powered by a mixture of liquid oxygen and hydrogen, 450 s. However, an ion thruster requires a lot of energy to achieve this exceptional level of performance. After all, the stronger the electric field, the faster the ions accelerate. The Chinese seem to have built a top-secret engine and are in no hurry to inform the scientific community about the nuances of their power plant. Maybe the secret itself is in the power plant, serving as the source of energy that meets the massive needs of this endeavor. In currently existing technical implementations of the ion engine, solar cells are used as a source of energy, which is required for fuel ionization. However, for flights into deep space and for establishing transport links with the Moon and Mars, ion engines with a capacity of 5 megawatts to 500 megawatts are needed. Where can we get this much energy when the solar panels on board the spacecraft do not provide anywhere near that much? For example, the Ivanpah STPP, located in California, USA, has a design capacity of 390 megawatts. The world's largest solar power plant, Ouarzazate Solar Power Station in Morocco, has a peak power of 580 megawatts, boasting an area of 300 square kilometers. Naturally, this is an unattainable value of production for a spacecraft for a variety of reasons. But it seems as though the cunning Chinese have something, and this certain something is now going to boggle your mind. In parallel with the development of new ion engines, Chinese scientists are developing nothing less than an orbital power plant. Space energy is the latest trend in space exploration. The technology looks something like this. Solar modules are launched into orbit and assembled into a single complex using robotic labor. The total capacity of the complex can reach 1.5 to 4.5 gigawatts and will be able to transmit electricity using a laser. The receiving module will be able to convert a laser beam or microwave stream into electricity with a conversion loss rate of approximately 50%. However, even knowing this, these are impressive results. It is not easy to implement such a project on the Earth. Back in 2012, Elon Musk spoke out vehemently against this technology, citing its extreme inefficiency. After all, the cost of such a system is so great that the cost of energy on Earth will turn out to be too high and therefore render it unprofitable. In addition, the effect of constant concentrated radiation on the Earth's atmosphere has not been fully investigated. Without fail, in the event of its destruction, we will all find ourselves in open space without leaving our homes. You have to convert photons to electrons, then back to photons, and then back to electrons. What is the efficiency here? This idea must be killed in the bud, was Elon's response when asked about the prospects for space energy. However, in outer space, these factors are not so significant. After all, the cost of energy for space stations is calculated in a different way and not by earthly means. Furthermore, it is impossible to harm outer space with radiation. It turns out that earthly obstacles and restrictions do not work in space. It is still necessary to get the money and finance the project. Note that China is in second place after the United States in their spending on space projects. Considering that the labor of engineers, designers, scientists, and even ordinary workers is much cheaper in China, the cost efficiency of the Chinese budget is noticeably higher. The total state space budget of the United States this year is approximately $58 billion. In China, this figure, according to some estimates, is about $8 billion. For example, in 2016, the United States spent $36 billion on its space program, while China spent less than $5 billion. Judging by these figures, the space race has already begun. Besides, how can Musk's words stop the Chinese? Let us recall the psychological complex of the little brother and the ambitions of the Chinese leadership to make China the #1 country in the world. If a promising Chinese orbital solar power plant can collect and transmit solar energy directly in space, then China will finally become a leader in space technology. This is of great concern to the United States, and it's not just about ambition. The fact is that virtually every space technology has military applications. This applies to literally everything, from the materials from which spacesuits are made to the shells of space shuttles. In the case of the orbiting solar power plant, there is also a military component. The laser beam can be easily converted into a directional energy weapon that incapacitates spaceships, satellites, and other infrastructure. In addition, important strategic objects on Earth can also turn into targets. It is this factor that worries the United States, which has long been implementing a program to attempt containment of China. How will the Americans cope? This is a difficult question. To contain China in space, the United States must first befriend the Russians, which is also not easy. We will be closely watching the space race. Subscribe to the channel so you do not miss anything.